In this webinar, we are going to talk about the art of picking numbers. And this webinar will be broadly divided into two parts. Okay, where first of all, I am going to talk about when to pick numbers. Okay, I get a lot of queries around this from a lot of students where they ask me, in which questions do you think we can take numbers? And the second question which they kind of ask is, and why should we pick numbers even if you're picking it in those cases? And what kind of numbers can we pick? Okay, so what I'm going to do is I'm going to just first of all talk about the various cases or various scenarios in which it makes sense for you to pick numbers. And I'm also going to talk about, with the help of a few questions, what kind of numbers can you pick? Because it's because in certain questions, like in different topics, maybe there are different ways or different kind of numbers that you can take. Okay, so broadly, these are the two things that I'm going to talk about, and I'm going to start off by talking about when to pick numbers. Okay, and I've broadly classified into a few cases. Once you understand that, it will be very easy to recognize the question and in which you need to pick numbers, and then we can talk about what kind of numbers you need to take. Okay, so the first scenario, which I think in which you can pick numbers, is questions which deal with must be true kind of questions where you are asked what is the say remainder, or if this is true, which of the following must be true. In those kind of questions, if you understand the question properly, and if you know, and there'll always be certain constraints which are given in the question, then you can use those constraints to figure out what kind of numbers you need to take. Like, for example, you must have seen questions where they give you certain constraints like this, right? If they tell you if x is say a positive integer, and they'll give you certain questions, and then they'll ask you which of the following must be true, right? In these kind of questions where we are given certain kind of constraints, like a positive integer or even number or a prime number, those kind of things, in those kind of questions, it definitely makes sense for you to take values and solve the question and get the answer. Okay. The second scenario in which you can pick number is, it's not necessary that you always have to have a must be true kind of question. There'll be certain questions where you'll be just given the constraints, okay? And these kind of constraints might limit the number of cases that you need to check. For example, as I told you, you might be given if x is a prime number, say, for example, prime number less than, say, 30, something like that. Or if they give you a range, say, for example, if x squared is less than 1, something like this. So if a certain constraint is given and you know that there are limited number of values that you need to check, then it makes sense for you to pick numbers and solve the question very quickly. Okay, but keep in mind the number of cases should be limited. Okay, if there are a lot of cases, and when I say a lot of cases, what I mean is if the number of cases that you are testing, say, exceeds 5 or 6, it kind of doesn't make sense. Because you'll be taking a lot of time to plug in these values and check. Okay, so make sure that you understand this part, how many numbers that you need to take and how many cases that you are trying to check. The third scenario is a question involving ratio and percentage, and I think this is one of my favorite areas where I love taking numbers, especially if you can, and especially for you, if you can recognize what kind of numbers you need to take and which kind of ratio and percentage questions in which you can take numbers. And I have a few questions, so don't worry. Whatever scenarios that I'm mentioning here, I will be showing you each and every. I'll be taking an example for each and every scenario and showing you how you can pick numbers in each and every scenario. So for ratio percentage, I'm going to take up a scenario of a question where I'll specifically show you what kind of things that you need to look into the question, which will give you an indication that yes, this is a question involving ratio percentages where I can definitely take numbers. Okay. And the last scenario is questions which deal with powers and ranges. And I'm sure you must have come across a lot of inequality questions where they talk about x squared is less than x cube, those kind of questions, right? Where there are a lot of powers, or they might ask you to arrange certain kind of powers like this by giving you some information about the variable where you have to arrange these. Now, even these kind of questions can be solved taking values if you understand what kind of values you need to put in. Because the major mistake when most of the mistake people make in this, especially inequalities, is because they miss some special cases like -1, 0, 1. These kind of cases, they tend to mess. But if you can understand what values need to take properly, if you make sure to take all the ones that you need to consider, your life can become easy while solving such questions. Okay, so long story short, these are the four major areas where I feel that you can always take numbers to solve the question. Okay, and I'm going to take up, as I told you, a few questions and explain how to go about it. So far, is everything clear? Do you have any doubts, any questions? If this is clear, please mark yes. So what I'm going to do now is I'm going to take up a few questions. And the process is, those of you who are attending it for the first time, let me tell you how the webinar is going to continue, is that I'm going to give you a question, okay? And I'll give you about 2.5 minutes to solve that question, depending on how many responses that I have. And then after that, I'm going to show you, say if you've chosen how to solve that question, number one. If you have chosen a wrong option, what are the probable reason for choosing that wrong option. Okay, so I can see it's clear to everyone. So let's get started. Let me give you the first question. Okay, and just a small request, don't put in responses in the chat box. Okay, there will be a poll. Put in your response in the poll. Okay, so here's the first question, guys, and let me bring up the poll. So you have to about 2.5 minutes to solve this. Okay, guys, another 30 seconds, then I'm going to end the poll. Ten seconds, guys. So those who haven't put in the responses, please do so very quickly. Then I'll end the poll. Okay, I'm ending the poll now. Okay, so tell me, guys, how did you find this question? Was this too difficult, easy? How was it? And you can put in a response in the chat box. Did you find this question easy, or was it tricky? How did you feel about this question? Okay, Mark says easy, Parvez says easy. Okay. Okay, so all of you found the question easy, which I agree. The question is, I would say, close to a 600 level question, 600. And I hope that all of you would get, most of you, in fact, not if not all, would get the correct answer. Now, the reason behind giving this question was to basically talk about the situation of must be true, and also to talk about the constraint that is given to you, which can help you decide what kind of numbers that you can take. Now, in a question where you are dealing with a prime number, okay, a lot of people have the tendency of just checking odd prime numbers. Especially if you're starting your prep, you may not be well aware of this fact that there is an even prime number also, which is 2. So you may end up missing it. But keep in mind, when you're solving a question by taking values, Okay, it is very important for you to consider basically all kind of scenarios. So if you're dealing with a prime number and you want to plug in values, make sure to consider cases of both even prime numbers and odd prime numbers. Don't just check for one of them. Okay, so if I have to check again, I would basically take up one even prime number because this is the only one that exists. For odd, it's up to you. You can take any one that you want to. Okay, that's number one thing that you should, after reading the question, you should infer, okay, if a prime number I want to test value, I would take one even, one odd. The second thing that you need to understand is that this is a must be true kind of a question. In must be true kind of question, the conditions that are given, they must be true for all values. Okay, keep this in mind. It should be true for all values. If any of these statement, if it is not true for even one case, if it is not true for even one case, then you have to discard that statement. And this is very important. Please keep in mind. Okay, so first thing is of taking even odd numbers. Second thing to keep in mind that if while substituting values and checking the cases, okay, if you come across a scenario where the condition is not being satisfied, then you can discard that particular statement and say, hey, this is not a must be true kind of a statement. Okay, now what you'll do is you'll take each statement one by one. So, and also going to talk about an alternative way also, guys, just to help you out. So notice this statement is saying p square minus p is divisible by 2. So I need to check whether this statement is true every time or not. So what I'm going to do is I'm going to take an even number, like say I'll say, okay, let's take p is equal to 2. Okay, and then p is equal to 2, and I'll do p square minus p. So p square would be, let me write it directly. P square minus p is 2 square minus 2, which is 2. And 2 is divisible by 2. So in this case, this is true. Then you take an odd prime number, say 3. Okay, 9 minus 3 is 6. 6 is also divisible by 2. So even this is true. So what you can say is that this statement must be true. Okay, if you want, for the sake of, say, if you are like worried that, hey, I might maybe making a mistake, you can take another case. You can take even 5 square minus 5 and check it very quickly. You'll see that in all these cases, even and odd prime number, you're always getting true. So this statement will turn out to be true. Okay, so that's the way you can plug in numbers and decide at least for one of these statements. Now I'm just going to this, since this is a slightly easy one, so I would just want to very quickly discuss the alternate, because the alternate method can be useful in some other question. Okay. Now, whenever in GMAT, GMAT loves considering these kind of scenarios, p square minus p, then something like this also, I would say. Okay, let me write it in a sequential order. Okay, GMAT loves these kind of expressions, and you need to understand the meaning of these so that in the exam, if you want, instead of plugging values, you can also directly infer. So if you see p square minus p, and if you take p common, okay, you'll notice that you'll get p times p minus 1. And again, I'm writing it this way. Now, what is the significance of p minus 1 times p? Can anyone tell me? What is so special about p minus 1 times p? Anyone? Why am I emphasizing on this? What is p minus 1 times p? You can type in your response in the chat box. Okay, Parvez says p times p minus was consecutive numbers, hence even odd, therefore product is even. Yes, absolutely good, Parvez. That's absolutely correct. So keep in mind that p minus 1 times p, they basically represent two consecutive numbers. If you'll notice, like 2 multiplied by 3, 4 multiplied by 5. So whenever you have two consecutive numbers will always have one number as odd and one as even. Okay, so the product is always going to be even. So if if you're able to recognize this, you'll be able to very quickly infer that, hey, as long as p is an integer, doesn't matter prime or non-prime, as long as it's an integer, p square minus p will always be divisible by 2. So this statement, irrespective of it being a prime number or not, will always be true. So you can save some time in the exam if you are able to understand this or remember this. Okay, also this expression, can anyone tell me what's so special about this one? I hope you understand now. If p minus 1 times p is two consecutive numbers, then p minus 1 times p plus 1, this is basically three consecutive numbers. Okay, so you should be able to understand or recognize this pattern in the exam so that you can make direct inferences regarding these kind of expressions. Okay, otherwise, obviously, this session, as I'm talking about taking values, you can always take values and move ahead and solve the question. Okay, now let's come to the second statement. The second statement is p square minus 1 times p plus 3 is divisible by 6. Once again, take p is equal to 2 and put it in the expression. Okay, so I'll get p square is 4 minus 1, p is 2. So notice in this case, you're getting 3 times 5 and 15 is not divisible by 6. It's not divisible by 6. That's the moment you're getting something which is not true, okay, you don't need to check for odd cases. For p 3, 5, 7, you don't need to check. You can say, hey, I'm not getting true in p is equal to 2, so I don't need to check further and I can say this is not true. This is true. This is not true. And you can directly move on to the third statement. There are again other ways to infer, but I'm not going into them now. But you could have used inference also to get the answer. But values, as you can see, can help you really fast to make that inference. In this case also, simply move with p is equal to 2. You put p here, 4 minus 1, 4 minus 9. Okay. And once again, you'll notice that you're getting odd numbers. This is 3, this is minus 5. You can again notice this will never be divisible by 16. So you'll say, hey, this is also not true. And then finally, you can mark your answer as, if I go back to the answer options, you will say that the correct answer is 1 only. Okay, so you keep in mind that when you're checking for a prime number, don't just check for odd primes. Make sure that you include odd and even prime both when you're taking values. Because if you're taking values and if you're not considering all possible scenarios, you may end up making mistake. Second is learning from this question is to keep in mind these kind of consecutive numbers form. If you can, then you may be able to make the inferences directly also. Okay, so thankfully, most of you, 72% of you got it correct, but the remaining 28% who made a mistake, I hope this is now perfectly clear and you don't have any doubts. I would request all of you to please mark yes if this is perfectly clear. Okay, great. I can see all of you have understood this, so well and good. I hope the learnings are perfect. So now let's move on to the next question, guys. And this is a very interesting question. And let me bring up the poll. So here's the poll also. Okay, guys, another 30 seconds. I request all of you to put in your responses, even if you're getting it wrong, that's totally okay. But whatever you're trying, whatever answer you're guessing and getting, kindly mark that in the poll. Ten seconds. Okay, I'm ending the poll now. Okay, as you can see, interesting result, almost two responses which are kind of clear favorite. One is A, where 31% of you think that the answer should be A, and about 37% of you think the answer should be D. And I have a few 18 and 12% also. So what do you think about this question? Was this difficult, easy? Okay, Vishal is asking, is it better to do it in a tabular form? Tabular, or you can use a tree structure also, Vishal, to get the answer. Both of these would have been totally okay. Okay, Melanie says easy. Yashika says easy, difficult. Parvez is difficult. This is, I would say, a 650 level question, guys. I wouldn't this as 700 plus. Okay. The main challenge in this question, frankly speaking, this question, there are two purposes of giving this question. One was obviously the very obvious purpose is to show you how to take numbers. Okay, but the other thing is a skill of translation, which is very very important, especially in word problem questions, whether you're able to understand what exactly is being asked. Okay, if that part is not clear, even after taking numbers and solving a question or simplifying your life, you will still end up making a mistake. Okay, so that's why I decided to choose this question. Now let me talk about the first part, taking numbers. Now, how do I decide in this case that I need to take numbers? So the first and the most obvious cue that you can see in the question, or the hint that you can take from the question, is if all the information that is given in the question is, say, in the form of a ratio, or say a fraction, or percentage. Okay, and obviously if the final answer, if that is the case, then the final answer that is being asked will also be asked in a ratio, fraction, or percentage. So if that is the case, then you can definitely take a number to solve the question. Okay, take values, take a convenient value, and solve the question. Now, if you notice in this question, I'm going to read it obviously properly from end to end, don't worry. But if I just look at the numbers, you'll see 4/5 a fraction, 3/4 a fraction, 75%. This is a percent, but obviously you can convert this also into a fraction and write it as 75 by 100, right? Which is 3/4. So all the information that is given in the question is in the form of a fraction. Okay, and the final answer that is also being asked is in the form of a fraction, and this could have been asked in a percentage, also doesn't matter. Okay, but as long as every information is in ratio fraction, final answer is in ratio fraction, you don't even need to think twice. That's a clear indication. Take value, solve the question. Obviously variable will also work, but take a simple value and move ahead. Okay. Now so if I have to take a value here, obviously the best value that I can, the easiest would be to take it as 100. So let me read it very quickly and see what I need to do here. Now, according to a survey, there was a survey done in the year 2010 in city C. 4/5 of its residents, okay, 4/5 of the residents of city C were born in city C. Okay, so what you can do is you can write this as, say that, hey, there are total 100 people in the 100 residents in, say, city C. Out of these, 4/5 are born in city C. So what you can do is you can break this down, because if they're born in city C, then it's obviously there are certain people who are not born in city C. So you can write it like this: born is 4/5. That means 4/5 of 100, right? Again, I'm writing each and every step down, but if you are comfortable with your calculations, you can obviously do this directly also, not a problem. But the point is to divide it into two parts. Again, you may not realize that you have to draw a tree structure, so you may write it randomly also. That's totally okay as long as you're writing it. Okay. Now, let's read the next part. They're saying of the residents who were born in city C. So now they're talking about these people who were born in city C. So of the residents, this is a reference point. It is a reference point. Of those who were born in city C, 3/4 were employed. Now, in the exam, whenever you see a structure like this, say, for example, there's some total which is divided into two parts, part one and part two, and either of these parts, if they are further segregated into two more parts, right? If that is the scenario, then that's an indication that it's best to draw a tree structure and solve the question also. Okay, so some people ask me when to use tree structure. This is the kind of hint that you need to take. Whatever is the total, it's divided into two parts. Now, one of the parts or both the parts would again be subdivided into two parts or more parts. It could be three also, doesn't matter, as long as they're getting subdivided. If that is getting subdivided, it makes sense for you to use a tree. Okay, so in this case, when I see that 3/4 are employed, that's an indication, hey, now they're dividing this into employed and unemployed. And 3/4 of whom, don't take 3/4 of 100. Please keep in mind, they're talking about of the residents who are born in CTC. So they're talking about 80. 3/4 of 80. So that would be 60. 3/4 of 80. They are employed. So the remaining are unemployed. So how many are unemployed? They are total 80. If 60 are employed, 20 are unemployed. Okay. So this part is done. And very important thing notice is that I am not reading everything in one go. I'm making sure that I'm breaking each and every part. A lot of people read it once very quickly, then they read it again. That's not a good strategy. Either while reading, you jot down the information in one corner, like you may end up writing it like this at one corner, 4/5 of total, okay, 3/4 of those born in C, right? Write it in one corner or write it in a form of a table if you can recognize that that's a table. But don't go and read the question twice. Reading twice does not make sense. You'll waste a lot of time. If there's some information that you're not using, okay, make a note of it, mental note of it, or write of it. I haven't used this, so I may need to go back. But if you're reading the whole question, especially if this is a 4 or 5 line question, if you have to read it again, then you are in trouble. You will never be able to complete the question within 2 to 3 minutes. Okay, so that's another advice which I would want you to take it seriously, because I've seen people reading twice, thrice, which is not a good way of solving. Okay, so now I've done till here. Now I'll read this part. If only 75% of city C's residents were employed. Now notice they're talking about all people, city C's residents. So this is my total city C's residents. They're telling this, out of this 75% are employed. So 75% of 100 is basically 75 only. So I know total 75 people are employed. Keep this in mind. Total 75 are employed, out of which 60 are employed here who are born in city C. Okay, so how many are left? We are left with 15, and those 15 obviously will come from here. So out of these 20 people who are not born, 15 are employed, and the remaining 5 would be unemployed. Okay, so I hope till this part it's perfectly clear. So see, now all my data is placed in my tree structure very properly. I know what each and every data means. I know I cluttered this a bit, but this was just to make you understand, but I hope everything is clear here. Now, the last part is where I think most of you ended up making a mistake. Now, those of you who marked the answer as 5 by 100, I think the 31% of you marked the answer as A. You did not read properly. And this is where the translation thing I was talking about, especially for 31% of people. Those who marked C, I think you made a calculation mistake, but I'll come to that. Now, let's see what they are asking. What they are asking basically. I'm looking for a fraction. What fraction? So I'm looking for a fraction. Okay, what fraction of, so this is, they're telling me what fraction of residents who weren't born in CTC. So this is my reference point, keep in mind. If I remove all the clutters and everything, when I'm looking for a fraction, when they say fraction of, they tell you the reference point. The reference point is residents who weren't born in CTC. Okay, of those people who weren't born in CTC, what are those people? It's like 20 of these people who were not born in CTC. How many were, what fraction of them were unemployed? So out of these, those who are not born, how many were unemployed? So they are asking about not born in CTC and those people who were not employed. So not employed, 5. Out of those, total is 20. So the answer in this case would be 1 by 4, which is option D. Okay, they are not asking you what fraction of the total people or anything like that who are unemployed and not born in CTC. They're asking you of those people who are not born in CTC. When they say of those of residents who are not born, that means that would become your reference point. And then see what are they asking. They're asking of these people how many were unemployed. Now tell me if this is perfectly clear or not, because only 37% of you got this correct. So please mark yes if this is clear. If there are any questions, ask in the chat box. I'll be more than happy to answer. So Saransh is saying A is the answer. No, Saransh, A is not the answer. I hope it's perfectly clear now. Mark is asking, how did you know that 15 not born in CTC were employed? That's a good question. See, I know that 60, Mark, I hope you understand that 60 were employed who were born in CTC. Okay, I hope that's clear. And they're telling me 75% of City C residents were employees of City C. That means total people, total 75 were employed. If total 75 were employed and 60 I know are those who are born in city C, where will that remaining 15 go? There's only one place for us to put it, and that's here. So see, 60 plus 15 is equal to 75. So total 75 are employed in city C. I hope that answers your query, Mark. Any other question, guys? Please feel free to ask. So I hope the learning from this question is perfectly clear, guys. Number one is obviously that if it's a question based on fraction percentages, feel free to use numbers. You can take any number that you want, 100, 200, 300. You'll still get the answer. Okay. Number two is the tree structure thing, that if you see that if the information is given in the form of, say, a particular thing is broken down into two parts, and that again is broken down sub broken down into another 2, 3 parts, then you can draw a tree structure to solve the question. Indresh is asking, can we do a matrix? I won't be solving it, but yes, you can do it in matrix. You have to do it like this: born in city C, not born in city C. You can draw a structure like this: employed, unemployed, and total. So a tree structure or a matrix is perfectly fine here. So yes, Indish, to answer your question, if you want to use a matrix like this to solve the question, you can. You have to write 100 here, this is a total, and then on the basis of whatever information that is given, you can move ahead and solve the question. I hope that answers your query, Indish. Vishal is asking, can we spend up to 3 minutes on these kind of questions? Um, Up to 3 minutes, I would say, would be slightly a lot. I would say 2.5 minutes or 2 minutes, not more than that. This is not a 700 level question, by the way. This, as I told you, this is between 650, 700. So I would still categorize it as a medium, slightly medium hard only because of the language. As far as the calculation is concerned, if you'll notice, the calculation is not a lot. These are very easy values that you'll get very quickly, Vishal. So if you are taking 3 minutes, then I would say you need to maybe practice a bit more so that you're able to solve this in 3 minutes, within 3 minutes. But main thing is the last learning here is to make sure that you are able to translate it properly. Else, after finding all the values, these values are easy: 100, 60, 15, 5. But if you don't understand what fraction are you looking for, you'll make a mistake. Okay. So long story short, 2.5 minutes, and very important for you to translate, because just taking numbers and not knowing what to do with them can backfire. But I can see that it's all of you have said yes, you have understood this. So guys, let me move on to the next question. Again, interesting one. And here is it. Okay. Let me reset the poll and let me bring up the poll. Okay, guys. So I've added the poll also. Once again, you have 2.5 minutes to solve this. Okay, guys, another 30 seconds. Okay, I'm going to end the poll now. So those of you who want to put in responses, please do so. Okay. Once again, a very interesting result. Only 37% of you think that the answer should be B. 25% of you think the answer should be C. 18% of you think that. So it's all over the place, as I can see, with ABC getting most of the votes. What do you think of this question? Was this difficult? Was the language difficult? Did you had a hard time translating the question? What's your take on this question? Okay, Shivi says hard one, I can't infer. Okay, what about these others? What about the others? Tricky in translation, taking values. Okay, Doris says medium high. Language didn't understood, complex language, difficult. Okay, frankly speaking, guys, the question as far as the question is concerned, it's not that difficult. Okay, when I show you the solution, you realize that it's like a 3 to 4 line kind of a solution, frankly speaking. Okay, as far as the calculation is concerned, the reason that this becomes difficult is the translation part. Okay, so once again, taking values is obviously one of the reasons which I wanted to discuss this, but the other thing which I want to talk about is your translation skills. If you are not good with this, taking values is not going to help you at all. Okay, so please keep this in mind. Once again, let's read it and see what can we do about this kind of a question. What is given to us? And maybe I'll show you a different way of doing it. We have already done tree structure already. Now in this question, notice they're saying that on a Sunday in a certain movie theater, these are all additional information not going to help us much. Of the total people, okay, so of the total people who visited the theater, okay, so I'm talking about all the people who have visited the theater. So we can, if you want, we can take this as 100, but we'll keep this in hand. We don't know whether this would be 100 or something else. But of the total people who visit the theater means they're talking about all the people. So most in, you can make an inference, hey, most probably this might turn out to be 100, okay? Of these people, 30% of them, okay, 30% of these 100 people had tickets for 3D films, and they also took popcorn. So these people, 30% people, so let's say if I take total people who visited the theater as 100, okay, I can say there are 30% people, again 30% is easy to calculate, that is 30 people, they had tickets for a 3D movie, and they're people who also having popcorn. Okay, now from here also you can kind of make a inference that saying, okay, 30 3D people, they have 3D films, and they also took popcorn. So there's a possibility that some of them might not be taking popcorn also. Okay, that's the kind of thing that you may have in mind, and you can move ahead reading and ahead seeing what else is given. Okay, now the next information given is if 25% of the people who had tickets for 3D film, okay, notice, of the people who had tickets for 3D films. So that, what is the meaning of this? They are basically trying to say there are certain number of people, okay, let me put it this way. There's a certain number of people who have taken 3D tickets. Some of them have taken popcorn, and the rest of them have not taken popcorn. Okay. Now, 25% of the people who had 3D tickets, so they're talking about the whole big chunk, all people who had ticket. Now, that information I don't have. Okay. All I know is that 30 of them had popcorn. I have no information about this. So what you can do is you can kind of assume something and move ahead. You can say, okay, I don't know how many people bought 3D films, but I've already assumed 100, so I don't want to assume any more number. I cannot assume any more number. I would say, okay, let's assume, say X people had 3D tickets. Okay, X people had 3D tickets, and they're saying 75% did not take popcorn. So can anyone tell me what percentage of people took popcorn? It's an easy question, so I hope you'll be able to answer this. What percent of people took popcorn? If 75% of these of people who had 3D tickets did not take popcorn, what percentage of people took popcorn? Yeah, it's correct, Navneet. Obviously 75 because it's 25 are not taking it. Total is obviously 100%. So I can say 75% of people who had 3D tickets, they took popcorn. Do we have this number with us? Do we know how much this is? People who took popcorn. And obviously they already have a ticket, 3D ticket. Do we have any information about this number who took popcorn and had 3D tickets? We have it, yes. We can see that that number is 30. That's we have already found that out. So we can say 75%, which is 3/4 of all the people who had 3D tickets. Out of that, 30 had 3D tickets and popcorn. So total people who had 3D tickets is basically 40. And the question is, of the total people, so keep in mind, percent of the total people. So the denominator will be total people. Of the total people, what percentage had 3D tickets? How many had 3D tickets? 40 had 3D tickets. So the answer is going to be 40. Correct answer is C. So notice, guys, what is important is for you to be able to translate it properly. If you're not able to translate, taking values might not help a lot. Okay, taking values makes your life simple while doing calculation, but unless and until in word problems, especially if you don't understand the meaning of the question, it will be very, very difficult to solve it. So you need to understand how these information relate to us. I'm very quickly explaining it again. There's already 100 people. 30% people had 3D films, were watching 3D films, and they were also taking popcorn. So I found out 30. And I was told 25% did not take popcorn, those who had 3D films. So I inferred, this was an inference that, okay, if 25 are not having popcorn, had 3D tickets, 75 obviously will have both. And from there, I found out how many had 3D tickets. Any questions at all? So 37% of you got correct. So the rest 63% of you who could not get it correct, that's totally okay. But please let me know if this is perfectly clear. If you have any questions, please ask. This is definitely a 7-level question, Navneet. I'm gradually increasing the difficulty level, but this is definitely the accuracy of these questions in GMAT Club, if you'll notice, would be close to 45% or something like that. Is this perfectly clear? So again, two purposes. Keep in mind, even if you learn to take values, it's very, very important for word problems questions, especially to ensure that you understand how to break down the sentences and frame the equation, which we call as translation. If you're not able to do that, taking value is just going to take you halfway. Okay, I can see about 15% if you're saying 15% of you saying you haven't understood it. Please ask question, guys. The purpose of this webinar is to help you understand. Okay, so if there are any questions at all, please feel to ask in the chat box. Okay, moving on. You can post in your queries. If you have any out here, I'll reply with the help of a chat. Okay. Now let's go to a question which is slightly different. Is asking, can you repeat the last part? Can you let me know what is the last part? I'll try and type it down for you. If you can tell me which last part are you talking about? For the others, 85% of you who have understood this, you can start off with the next question. Okay, everyone's asking, two people are asking. So guys, just give me a minute. I'll go back very quickly and explain those. Just give me 2 minutes. Krishna, I hope this part is clear that you're getting 30 people are having both. This information, 25% of people who had tickets for 3D films did not take popcorn. So they are talking about 25% of people who had 3D tickets but not taking popcorn. 3D plus NP means not taking popcorn. Okay, so these all people who had 3D tickets, all people, keep in mind, all people, 25% are not taking popcorn. So you can say, right, that 75% will be taking popcorn, because that's how you can divide it, right? 25 cent, where they told 100% people who are watching 3D tickets. Out of this, 25 not having popcorn. So 75% of these number of people who are watching 3D are having popcorn. That's number this number I already have, which is 30. I already have this. So that's what I'm writing. 75% of X. X is what? All people who are watching 3D. That is equal to 30. So from here, I can cancel this out and get X as 40, which is the number of people who had 3D tickets. So this number is basically 40. Okay, I hope it's clear. If you still have doubts, uh, you can ask in the chat box. I'll try to answer there. For the rest, kindly try out this one. And if it's clear, please let me know. Gurvansh, Krishna, if the last part is clear. Meta, you can improve translation in two ways. One is obviously the very obvious way is practicing. The second is, and the most important one, while solving question is to be able to break down the sentences. Most people read questions, as I told you, word problem questions, in my opinion, in one go. Okay, read everything in one go and try to solve the question after reading it once, or going through the question again and again. That's not the right way of solving questions. If you notice, I keep on making brackets after each and every part that I've read, so that I know exactly what I am writing down. If you can practice by doing in the same way, at least during the when you're solving official guide questions or questions on any particular course, try and see if you can break down each and every sentence properly or not. If you're able to do that, your translation skill will definitely improve. So final recommendation, if I ask me, is don't read it in one go. Break each sentence down, make sure that all information is there in your paper. That can definitely help you frame the equations easily. This is an easy one, so I won't spend a lot of time. I won't be giving you a lot of time in this one. I'll give you just another 30 seconds. Would want you to mark this one quickly. Okay, I'm going to end the poll in 10 seconds. Request all of you to put in your responses. Okay, I'm ending the poll now. Okay, guys, tell me, how was this question? Difficult, easy? 65% of you think the answer should be C. Okay, Doris is writing, actually, it might be E. Okay, we'll talk about E. But those of you who marked C, or a few of you also marked A, B, and D. Okay, Aida says hard, Vishal says easy, Pooja says easy, easier than the previous one. Doris says easy if you remember. That's a good point, Doris. Shivi says easy. Parvez says answer is E. By mistake took, okay, easy if you know the concept. Okay, this is an easy question if, as Doris has mentioned, so he has mentioned in a private chat. So let me tell you what exactly he said. If you remember that 0 is an integer, that's what he's saying. Now, this is the question in which most of you, I know, will falter and mark the answer as C, which is incorrect. So let me put it this point first. This is incorrect. Why is this incorrect? See, when you're taking numbers or even making inferences, the major mistake that most of you make is that when you read X as an integer, almost, I would say majority, 90% more than that, people always think about only positive integer. And this is something which I almost take one question each webinar that I take to highlight this point, reiterate this point to everybody, that guys, if you're given X is an integer, please make sure to infer that that integer could be positive, it could be negative, and that integer could be 0. All possibilities exist. Please do not think that if x is an integer, then it will only be a positive integer. Is this part clear? Yes, no. In fact, don't answer that question. Answer this question. How many of you just assumed positive integer and solved the question? If you took positive integer, mark yes. If you took positive, just positive integer, mark yes. If you took negative, if you considered everything, mark no. Okay, I can see all of you are saying that you, okay, now the percentage is changing a bit. Okay, Sangeeta is saying yes. Okay, I can see most of you, about 90% of you are saying that you just considered positive. So I hope you understand this, guys. This is a very important lesson. It's not only for number properties, it's for algebra, any kind of question where you're dealing with a constraint. When you're dealing with a constraint, make sure that you consider all these three. Okay, if it was given that x is a positive integer, then you could have considered 1, 2, 3, and so on and so forth. Otherwise, don't. Okay, now in this question, the question is fairly easy. You've been given this expression. You've been asked the unit digit. And those of you don't know, the unit digit is only dependent on the units digit only. So this expression, instead of writing 435 to the power x, 3, 4, 5, 1 to the power 32 and 9, 8, 5, 6 to the power 2x, you can reduce this and write it as 5 to the power x, 1 to the power 32, and 6 to the power 2x. Okay, because you're only interested in the units digit. Once you have this, you should definitely make two cases, at least two cases. If you want, you can make all these three cases. One is when x is a positive integer, when you take x as positive, like 1, 2, 3, 4. In such cases, in the first case, the value of 5 to the power x, when you're considering as positive, is always 5. So you don't need to worry about it. 5 to the power 1 is 5, 5 to the power 2 is 5, 5 to the power 3 is 5, no worries. 1 to the power 32 is always 1, so this is not a problem. And 6 to the power something, again, positive, is always 6. So 6 square is 36, 6 cube is 216. So when you take this case, the unit digit turns out to be 2. 6 plus 6 plus 6 is 12, so the unit digit is 2. And that is what most of you marked the answer as. 65% of you did this, which and I hope you understand why this is wrong. The second and the easiest case that you could have taken is you could have simply put x equal to 0. Okay, you could have said, hey, what happens when x is equal to 0? Now 5 to the power 0, if you put x equal to 0, you'll get 1 plus 1 plus 1. And notice that you're getting contradictory answers. When you had taken positive, you are getting the unit digit as 2. When you're taking 0, you're getting the unit digit as 3. Since you're not getting a unique answer, the correct answer would be option E, cannot be determined. Okay, so I hope, guys, this is perfectly clear. Please mark yes if this is clear. If you have any questions, feel free to ask in the chat box. Okay, Pooja is saying 0 is not an integer. Pooja, 0 is an integer. Don't. It is definitely an integer. What you need to keep in mind is that it is not a positive integer, Pooja. Okay, but it is definitely an integer. Shivit, that's totally okay. That you forgot to consider 0 negative. The idea of this webinar is to help you understand that people do it. Now you've made a mistake. Make sure that you make a note of it. Whenever you see an integer, that is the see. I'm not writing this just because I want to teach you guys. When I solve a question, also I write these stuff down. Okay. Obviously, while explaining, I'm slowing. I'm teaching you very slowly. But in the exam, my mind works in this way only. If I see an integer, I just very quickly write down this on my piece of paper. You don't have to write it elaborately, but at least write it in this way so that you remember you need to consider all cases. Okay. I have a few more questions. Deepak is asking, can unit digits also be of decimal? Sangeeta is asking, can we use negative integers? Okay, all of you are asking about negative integers. That's a good question. See, understand the reason I did not take it because I am getting a different answer in these two cases. But you're more than welcome to take a negative integer and solve it also, like something like this. Okay. And then added up, 1 by 5 is 0.2, 1. Okay, 1 by 6, you will take it as 0.167, right? You can do it this way. Okay, if you want to write it 1666, you can do that also. That's not a problem, but because this would be a recurring one. Now, the question about decimal having a unit digit, then guys, yes, please keep in mind decimals also have unit digit. For example, if I write 157.295, just giving a random example, keep in mind this number also has unit digit, just a placeholder. Okay, so decimals also have placeholders. So this would be the units, this would be the tens, this would be the hundreds digit. Okay, so even if you get a decimal value like -1, -2, -3, you can put these values. You don't need to in the exam, but you can say, hey, I'll get different answers for different values that I'm putting here. So if you put 2 here, 1/25, you'll get something else. So I hope you get the point. But you will get an answer in this case also. The answer might be totally different, but you'll still get an answer. Okay. So I hope, Deepak, that answers your query. Doris is asking what GMAT level. This is 650 level. The reason for it being a 650 is just because of the trap, nothing else. The question in itself is easy. Sometimes because of these traps, the questions, the difficulty of these questions are increased. Okay. So I hope this is perfectly clear. One small thing which I think most of you know, but since somebody mentioned about zero, I'm writing this down. You can make a note of it very quickly. So when you're dealing with positive integers, okay, and I'm talking in terms of integers, positive integers always start from 1. So 1, 2, 3, 4, 5, so on. Negative integers starts from -1. So -1, -2, -3, -4, so on and so forth. Okay. When you're dealing with a non-negative integer, non-negative means kind of positive, but when you see the word non-negative explicitly being mentioned, you need to consider 0 in it also. So 0, 1, 2, 3, 4, so on and so forth. And if you see a non-positive integer, in that case, you need to consider 0 again. So 0, -1, -2, -3, -4, and so on and so forth. GMAT does use this one a lot. Non-negative integers, non-positive, I haven't seen a lot, but this is something that I think it's important. If not for this question, then for some other question, it might be helpful. Okay, so these are the 4 categories that you need to keep in mind. And if you just see the word integers, then you need to consider all cases, positive, negative, and 0, all 3 of them. Okay. Okay, I don't see any more questions in the chat box, which is good. So guys, let's move on to the next question. Okay, here's the next one. And let me bring up the poll. So I added the poll, guys, and you have 2 minutes to solve this. Okay, guys, I've already given you close to 3 minutes now. I'll give you another 30 seconds. I know this is slightly, I would say, calculation intensive. So I'm giving you 30 seconds more. 10 seconds. I have very few responses. So I request most of you to put in your response. It's okay if you get it wrong, but we have now spent close to 4 minutes. So I'm going to end the poll now. So whatever answer that you've got, you can just plug it in the answer choices. Okay. So at 50% of you think that the answer should be D, and I have again a few A, B, and C's. What did you think about this question? Because I almost gave you close to 4.5 minutes for this question. Did you find it really difficult? So thoughts, guys, what do you think of this question? Okay, Deepak says lengthy calculation, Parvesh says hard. Okay, hard. Doris also says hard, challenging. Okay, Medha says difficult. Okay, this is definitely a 700 level question. But again, two things here also. The same two things which I'm going to reiterate. In fact, three, I would say. Obviously, you should also have some kind of conceptual knowledge about time and work also. If you're not aware of how to solve time and work questions, and say, for example, if you are used to solving questions using unit work, then the calculation might become really lengthy for you. So having conceptual knowledge in this case is also important. So those of you who are not able to do it because of the lack of conceptual clarity, it's okay. But it's important that you go through time and work if you don't know how to solve such questions. What I'm going to do is I'm going to solve this question by using just one formula. Okay, that formula is basically work is rate multiplied by time. This is the only formula that I'm going to use to solve the whole question. Okay. And in a time and work question or in a time and distance question, what I basically do is I create a work rate time kind of a table for myself so that I can jot down all the information that is given to me in a single place. I write it like this: work, rate, and time. And whatever information they'll give is given in the question, I'll keep on jotting them in this particular table. I'll do my calculations here and so on and so forth. Okay, so let's make this table and see and jot down whatever is given. And starting with the first part, again, I'm breaking it down slowly, steadily, and reading it. So Ross can paint the walls of his dormitory in 12 hours. So he can do a particular work, which is painting, in 12 hours. So what I'm going to do is I'm going to write Ross. I don't know the work, so I'll leave it like this. I know this is 12 hours, so I'll plug in 12 hours here. Okay. His friend Ryan and Jack each, so they're talking about each, so it's important to make sure that you focus on these small words and don't just think that they are together. They each, working alone, can paint the same wall in 15 and 20 hours respectively. So Ryan can paint it in 15 hours. So I'll write that down. Ryan, 15 hours, and Jack is T hours. Jotted that down. Okay, nothing else that I can do here. So these two lines properly taken care of. Okay, now let's see what else is given. Now they're talking of a Sunday morning. So they're talking about one particular instance. So this is generally they can do the work in this and this hour. Now they're saying on Monday morning, Ross starts to paint his dormitory wall alone, and 4 hours later, Ryan joins him. Okay. Now notice they're talking about a specific situation. So what you can do is you can either create a separate table very quickly, or if you want, you can plug it below only, making sure that you understand that this is a separate case. So this is one case. Now they're talking about a Sunday morning. So you can write this down and saying, hey, Jack started the work alone. He worked for 4 hours and then Ryan joined him. Okay, so I'll write it down. Okay. On Sunday morning, Ross started to paint his wall alone, and 4 hours later, Ryan joins him. After another 4 hours, Jack joins him. Now, Ross has already worked for 4 hours, and they're saying after another 4 hours. That means Ross has worked for another 4 hours, and Ryan has worked for 4 hours. And after that, Jack is joining. This part is extremely critical, so I hope this is perfectly clear, because when Ross started, he worked for 4 hours. Ryan joined him, and after another 4 hours. So total Ross has worked 8 hours so far, and Ryan joined after 4 hours, so he has worked for 4 hours. That is an information that you should be able to break down and write properly. Okay. And after Jack has joined, Ross, Ryan, Jack together paint the wall in 20 minutes. So whatever is remaining, they're completing it in 20 minutes. So each of them after Jack joins are working for 20 minutes. And see, notice everything is in hours. In fact, you should write hours on top only so that you don't have to write it again and again. You can see 20 minutes is basically 1/3, right? So you can say each of them worked for 1/3 hour more. Okay, now I'll pause here so that I can ask you this question, that so far, that is the table clear or not? All the information that I've jotted down, is this part clear or not? Please mark yes if this is clear. Okay, because if this is clear, half the job is done. After that, it's very easy to solve the question. Okay, everyone's saying yes. So notice the way I've written down the information. This is very crucial, very important, especially when you're solving difficult questions, if you can jot this down. Okay, now let me write this down. This is 8 plus 1. This is 25 by 3. This is 4 to the 12, 13 by 3. And this is 1 by 3. Okay, so I've jotted this down also. Now, to solve a question like this, you always need to assume the work as something. Okay, this is where the assumption of number comes into picture. And in a time and work question, the work we usually take as the LCM of, say, the time that is given to us. Like Ross Ryan is given as 12:15. So we can take the LCM as of 12 and 15 and say, let's assume the work as 60. It's up to you. You can take 60, you can take 120, 180, whatever you want. But the basic that you need to take is 60, and 60 is the whole work. Please keep in mind that's the whole work. Now, also important thing to write here is that the first three row talks about the whole work, right? Jack does the whole thing in 12 hours. Ryan does the whole thing in 15 hours. And this is like they're doing it partially, right? This partial work, partial work, partial work. So you can say this is 60, this is 60, this is 60. Okay. Now, what is the use of this? The use of this is that now I'm using just this formula. Notice I'll use this. Obviously, I'll be using this form. Rate is what? Work upon time. So I'll say my work is 60 and Ross can complete it in 12 hours. So his rate of working is basically 60 by 12, which is 5 units per hour. So if I write this as units, I'll say unit per hour. Okay. Ryan is doing 60 units of work in 15 hours. So he's basically doing, his rate of doing work is basically 4 units per hour. And I don't know the value of t. This is what I need to find out, what is the value of t. So I'll leave it as is. You want to write, you can write 60 by t, but that's not going to help us much. But I'll leave this column. Okay, but I know the rate, and I should be happy that I know the rate, is because now I can plug in the rates. The rates never change. This is the rate they are working with. So I know the rates out here. This is 5, this is 4. I know that they are working for 25, like Ross has worked for 25 by 3 hours when they were working on Sunday morning. I know his rate is 5. So I can find out using just one formula, this formula that I'm using, how much work has he done. Work is rate multiplied by time. So 5 multiplied by 25 by 3, which is 125 by 3. I know Ryan's rate is 4. He's working for 13 by 3 hours. So 4 multiplied by 13 by 3 hours, which is 52 by 3. Okay, so Ross has done this much work. Ryan has done this much work. Again, I'll pause at this point because I want to be sure that this is perfectly clear. Please mark yes if till here it is perfectly clear. What I did was I knew the time 12 and 15. I assumed the work and found the rate. And once I knew the rate, what I did was I found out using the rate and the time that it worked for, how much have they completed. So Ross did this much, Ryan did this much. And notice an interesting thing, that I know my total work. I know my total work is 60. Out of 60, if Ross has done 125 by 3 and Ryan has done 52 by 3, I can subtract 125 by 3 and 52 by 3, okay, from 60 to find out how much work Jack has done, because together they completed painting the wall. If the total wall is 60 units and these are doing 125 by 3 and 52 by 3, whatever is remaining is the work which is done by Jack. Now, let me write this as, if you add these two, you'll get 177 by 3, which is 180 minus 177 by 3, which is 3 by 3, which is 1. So Jack did just 1 unit. Okay, Jack did 1 unit in 1 by 3 hour. So I can find out the rate of Jack. Rate of Jack is what? Work upon time. Work is 1 unit, time is 1/3. So this would give you 3 units per hour. And notice, why is this important? Because I'm trying to find out T. The only thing that is stopping me from finding out P is the rate. And now I know Jack's rate is 3. The moment I know Jack's rate is 3, I can plug it here. Time is basically work upon rate, using the same formula in a different form, that's all. I'll plug it here and get my answer as 20 hours. So the correct answer is option D. So tell me if you have any doubts, ask if you have any questions, but notice the way I'm writing stuff down. This, especially in difficult questions, framing the table, making sure that you're jotting down the right information in the right way can help you solve the question really easily, really quickly. If you have written the same information in a scattered form, right? Like for example, a lot of people solve question like this. They write work 60, Ross is here, Ryan is somewhere here, Jack is floating somewhere here, scenario 1 is here, scenario 2 is here, then you'll never get the answer. Or even if you get it, you'll be spending 3 to 4 minutes or more than that to get the answer. But you know, the moment you know that, hey, it's a time and work question, a time and work question deals with a work, right, a WRT table. So let me draw the table. You may have drawn 2 tables, that's quite possible, but all your information is in one particular table. So this will help you get your answers very quickly. Okay, let me see. There are a lot of questions on the chat box. Okay. Saransh is saying lengthy, any shortcut? Saransh, this is the shortest way in which you can do the question. It may seem lengthy because I was explaining it step by step by step by step. If you notice the calculation that I've done, how much calculation I've done? I found 5 here. Okay. I found 4 here. Okay. I had to find 125 by 3, 52 by 3, and the work left. These two calculations were very easy. This two calculation was simple multiplication. The only mistake that you could have made was here, the 5th calculation that I was doing. This is a place where you could have made a mistake. So you had to be careful here. After that, these two calculations, the 6th and the 7th calculation, was not that difficult. But if you're looking for an easier way, there isn't one. The other way to solve question is to take your work as 1 unit. If you go with 1 unit, all your value that you have in the table will be fractions, and that would take a lot of time for you to solve the question. Okay, Srikujan is asking, why was the LCM taken? The LCM was taken, so the work that you're working with, so when you're using the formula work is equal to rate multiplied by time, you can take the work as anything that you want. So you can take it as 1 unit, 60 unit. The reason I'm taking the LCM is because so that I get my rate in a integer form. Okay, to get the rate in the integer form, it is best to take the work as the LCM of the time. If you take the work as the LCM of the time, the rates that you will get would be in the integer form, and that would be easier to work with. Okay, Navneet is asking, ideally, how much time should be spent on this? So in this question, if you spend 3 minutes, it's totally okay. 3 minutes is, I would say, a good amount of time. At the max, 3.5 minutes. That's the reason I gave you 4 minutes. I know 4.5 minutes, because I knew if you're doing it for the first time, if you haven't done time and work before, you may take time. But this is a 700 plus level question. So here, spending 3.5 minutes is totally justified. That's not a problem at all. Okay. Okay, she was asking, can you help me with Jack joining the work? What exactly do you need help with that? When Jack joins, they are working. So I didn't get your question, CV. So if you can explain what exactly you're asking. When Jack joins, basically they're working for 20 minutes, all 3 of them. So 20 minutes is basically 1/3 hour, so 20 by 60. Okay, so that is the amount of time that I added in all 3 of them, because they were all working for 1/3. Okay, Saksham is asking LCM doesn't contain the time of Jack, so how can we calculate the total work? That is totally okay if the time of Jack is not considered, as long as we are working with one single work. So if you take it 60, if you want to consider, say, if you want to really make sure that hey, everything is included, you could have taken your work as 60T also. Okay, but then you would have a lot of T's everywhere. It doesn't make sense to have it. Okay, and if you want to really understand why this LCM thing works, I would suggest Saksham to go through time and work. If you if you go through our module, you'll see I have explained in detail why the LCM method works really easily. Okay, and why not taking T into consideration will also work. Okay, last question from Doris, which is, do you recommend skipping um, questions on the GMAT overall? Do you recommend skipping questions on the, when you say skipping, are you talking about this question or in general? If you're talking in general, then well, the answer for both this question is depends. Okay, it depends on how much time do you have when you come across a question like this. So for example, if this is a question which is like in the first 15 or 14, I would maybe still spend time, 3.5 minutes to see if I can get it. But after, if say 1.5, 2 minutes, if I see I'm not going anywhere, Doris, then I would ideally skip it. So in general, also the same thing applies. If you're skipping questions, please take that call within the 1.5, 2 minutes only. Don't spend 4 minutes or 3 minutes and then say, hey, I don't think I can get the answer. So the key, the thumb rule is you read a question, you jot down information, you try and see if you can figure out a way of solving it. If you understand the way of solving, you know the way of solving it, then spend time and get that correct, especially if it's in the first half of the exam. Okay, and if you're not sure what you need to do with this information, no idea at all, skip it, because you might get a better question, or the next one, or if you don't skip it, then you will be wasting time doing that question, and you may in the end may miss out certain questions also. So long story short, within 1.5, 2 minutes, decide. If you know it, move ahead, take more time and do it. If you don't know it, skip and go to the next one. Okay, so I hope this answers your query. Guys, very quickly, again, yes and no poll. Is this perfectly clear now? I tried to answer all the queries. I hope there are no more doubts in this one. Okay, that's great. Okay, let's move on to the sixth question. And let me bring up the poll. Once again, if you still have any questions in the previous one, feel free to ask in the chat box. I'll try my best to answer it. Another 30 seconds, guys, then I'm going to end the poll. Ram, you can mark the answer in the poll. You don't need to put it in the chat box. Okay, guys, I'm ending the poll now. Okay, most of you chose 0 as the answer, and quite a few chose option E, 29%, and there are a few B, C's, and D's. Okay, how did you find this question? Was this difficult, easy? That's totally okay, Ram. That's totally okay. That's not a problem. I was about to end it also. That's totally fine. Okay, so tell me, guys, what do you think of this question? Was this difficult or easy? Were you able to plug in numbers easily, or were you having a hard time? Okay, Pooja says tricky. What about the others? Meda says medium. Okay. Shivi says difficult. I've seen most of the people, if they don't kind of are not able to figure that out, most of you end up marking the answer as 0. But I kind of get a feeling that those of you marked A kind of guessed it, that, hey, it's a remainder question, so maybe it may be 0 kind of a thing. Okay. Saksham says confused between B and E. Okay, easy if you can. Navneet, I think you meant the expression, but yeah, easy if you can break down the expression properly, then it becomes easy. So, guys, I know the session is about taking numbers, but I also wanted to talk about the drawback of sometimes taking numbers. This is a question where taking numbers blindly, like just plugging in numbers, is not helpful. I think I told in the starting, we look for questions where we know a certain kind of number will work. If you know a certain kind of number will work, then it makes sense for you to plug numbers. But if you're not sure what numbers, so we're just given x is a positive integer. And if, say, after plugging, say, x is equal to, say, 1 and 2, if you see you're not getting the correct answer, then that is a kind of indicator, hey, that I might be making some mistake because I'm not reaching where I want to reach. So let me try and see if I can do something with that expression. Okay, that's how I go about it. Maybe I take some value, I take x equal to 1, maybe 2. And if I see all conditions that are given in the question is not working out, that's the moment I stop taking values. Okay, and then I try and look for a methodical way to solve the question. Okay. And when I say methodical way, it could mean anything. Since there's a number properties kind of a question where I have an expression, so methodical way would mean I will try and simplify. Okay, in a word problem question, I might take up a variable and try to set up equation. Okay, it could mean any of these things when we are taking values and solving question if it's not working. And in this question, especially, what's the problem is that you have been given an additional constraint. There are two constraints, basically. One is that it's a positive integer. So that is an easy one to work with. But the problem is with this part. You have been given another information that you'll have to work with, which is that n is not divisible by 5. So you need to make sure that you take a value of x which satisfies both the condition. Okay, you just cannot take x equal to 1 and hope everything will fit in. And that is why you might be finding slightly difficult to plug in values and solve the question. So in this case, what I'll do is I'll take up a value and try and solve the. I'll show you if I take up a value, what happens. So for example, if I take x equal to 1, okay, when I take x equal to 1, what's happening here is I'll get something like this, right? 1 minus 3 whole square plus 2 times 1 minus 3. Now n is equal to, this is minus 2 whole square, which is 4. And here you are getting 2, wait, let me write it like this. You'll get a minus sign and minus 4. So notice that here you're getting a 0. Okay. Now the problem here is that the value x equal to 1, this condition you were able to satisfy, but you did not focus on this condition. So most of you end up marking A as the answer. You were not focusing on this part. N is not divisible by 5. That's perfectly given. So if n is not divisible by 5, the remainder cannot be 0. You could have reasoned that out with yourself. When those of you who marked A as the answer, 37% of you, you could have reasoned out and said, if it is not divisible, then can the remainder be 0? It cannot be. So taking values as x equal to 1 will not work. And that is the moment you may want to stop, because there are two conditions that you need to fulfill. So you'll say, okay, let me leave this. Let me try and see if I can work with the expression or not. Okay, so let me go to the next slide and show you what you could have done. What you can notice here is that x squared minus 3x is present in both the expressions. As I was talking, remember I was talking about GMAT like working with these kind of values, right? I was talking to you about these cases. The other most frequently kind of things that GMAT likes to work with is taking common. I know it might sound trivial, but taking common while taking expressions, working with a square minus b square, working with a minus b or a plus b whole square. So when you're dealing with an expression, always try and look for these kind of things. If taking values does not work in the first go. So what you can do is you can think, okay, can I take anything common and see something can work with or not? Or can I use a square minus b square or a plus b whole square? So can something like this work? Now in this case, it's very clear that x square minus 3 square is minus 3x. It's present in both of them. So what you can do is you can take x square minus 3x common. Okay, so if you take x square minus 3x whole square from that one common, you'll be left with x square minus 3x. And from this expression, if you take x square minus 3x common, you'll be left with 2. I hope this part is perfectly clear. Okay, so let me very quickly put up a poll because some people get confused with this. So let me add a poll. I hope this taking common part is perfectly clear. Okay, I can see the chat now. Yashika is saying that, yeah, Yashika, that's basically what I was talking about. That's what I'm going to basically show you now. Okay, so I can see it's clear to everyone. Good. So now notice in this also you can take x out common. So you can write this as, you take x common, you get x times x minus 3. Okay, and this is a quadratic equation. Notice that you have x square minus 3x plus 2, which can be broken down, okay, and written as x minus 1 times x minus 2. If you'll notice, you'll get x squared minus, I'm not going into the specifics of breaking it down because that's not the purpose of here to teach you quadratic, but this quadratic equation can be written like this. Now I'll come to this part. Notice whenever I see a minus 1, minus 2, minus 3, something like this, it's best to frame it in the way that you can understand it easily. So x minus 3, x minus 2, x minus 1, x. Notice here I'm also dealing with consecutive numbers. Consecutive integers, by the way, because x is a positive integer. And these are 4 consecutive integers. And if these are 4 consecutive integers and they are not divisible by 5, that means none of the numbers can be divisible by 5. So now you can say, hey, these are 4 consecutive integers. So let me take it as 1, 2, 3, 4. Now you can take values, not a problem. I just need to make sure that n is any 4 consecutive integer. As long as there is any 4 consecutive integer which is not divisible by 5, it will work. You can take n is equal to 11, 12, 13, 14. Does not matter. As long as none of the numbers are a multiple of 5. Is this part clear, guys? Please mark yes if this is perfectly clear. That is not x, that is a multiplication sign, by the way. That's a multiplication sign. That's a multiplication sign. Okay. That's totally fine. That's totally okay. What other questions are people? Ishita is saying, why only 2? Where have I taken only 2? Where? Okay, I hope Ishita now is perfectly clear. I think you were also thinking this as x, but this is a multiplication sign, just to be very clear. So now you can see that you have 4. Now you can just divide it by x, divided by 5, because that's the question asking. You can divide this by 5 and find out your answer. This is 24. 24 by 5 will give you the remainder as 4. So the correct answer in this case is option A, which I think about 20% if you got it correct. But Ishita, there's no 2x. The expression does not have a 2x. Keep in mind this is 2 multiplied by x square minus 3x. So let me just remove it to, this is like this. I'm taking x square minus 3x common out of it. Okay, so I'll be just left with 2, nothing else. Okay. Any other queries, guys? If this is clear, please mark yes. Okay, Meda is saying, can you repeat the consecutive portion? So Meda, keep in mind that in GMAT, you may come across terms which will look something like this, P minus. I did not write it properly, but it will look something like this, P minus 1, P p plus 1 or p minus 1, p minus 2, p minus 3. So you should be on the lookout of numbers of expressions which are kind of, they look consecutive. The moment you see this, try and frame them in that particular order: x minus 3, x minus 2, x minus 1, x. So this is basically, if you plot it on a number line, you'll see these are consecutive number. You add 1 to it, you'll get x minus 2. You add 1 to it, you get another you add 1 to it. Okay, so these are 4 consecutive numbers. 4 consecutive numbers which are not divisible by 5. If they're not divisible by 5, that means these 4 numbers have to be something which do not have a multiple of 5. So you can take it as 1, 2, 3, 4, okay, or 6, 7, 8, 9, something like this. It should not have a 5 in it. Okay, as long as it does not have a 5 in it, you can take any 4 numbers to solve the question. Okay, Shivi saying observation is key in such questions. Taking common made it easy. Yes, Shivi. So what I'm trying to say is, you're absolutely correct that it basically, Diksha, you can try putting x equal to 2. You'll still not get the answer. If you put x equal to 2, n would again come out to be 0. You can try it out once, but you will see that n will still turn out to be 0. Okay, either is asking, can I access these? Either you can, we'll be sharing, I'll be sharing the link with you. We usually upload these webinars, so you can look at the explanation later on also. Okay. Again, as I was saying, that you need to have a methodical approach, always a backup plan for you when you're solving questions by taking numbers. Okay, so whenever you're dealing with a question like this, what you should definitely do is, there's no harm in taking values, but the moment you take a value and see you're not getting the answer and there's an additional constraint, these are observations, by the way, that you need to satisfy, that is the moment you should stop taking values and try and move to the methodical way. Okay, in the exam, keep in mind, you should always start with the first method that comes in your mind. That's totally okay. But if by going with that method, if at any point of time you feel that it's not working out, pause, move on, and just pivot and do something else. So if taking numbers doesn't work, that will be an indication, hey, I need to go to the methodical way. And always try and learn 1 or 2 ways of solving a question. Don't always stick to just one method. That's another recommendation that I would give, especially if you're targeting a Q50. Sometimes one method that you're learning may not work out. Like taking values might not work out, but in that case, you need to move on to the next one. Okay, Parvez is asking webinar. Okay, I'll come to that, Parvez, just very quickly. What's the last? See what I can see. We can eliminate answers as soon as we see last step as taking 1, 2. Exactly. So that's the point which I'm trying to make here, is that, see, if you put x equal to, I put x equal to 1, right? And why was I was getting 0? Because if you put in this expression, the expression that you have got here, notice if you put x equal to 1, x equal to 2, or x equal to 3, you'll always get 0. In this expression, you always end up getting 0. But in the exam, if you are just focusing on taking numbers, you might not realize. What you'll do is you'll be solving question just blindly without realizing what's happening. So you'll put x equal to 1, you'll put x equal to 2, you'll put x equal to 3. Each time you'll end up getting 0. Your mind might not work really well at that point of time under pressure, and you may mark 0, forgetting about this constraint. And that's wrong. Okay, so keeping in mind the constraint is important, and if you can do that, you should be able to realize that, hey, taking numbers is not working. So let me move on to the methodical way. Okay, guys. So that is it from my end for today. There are still 2 more questions in this presentation, which I'm going to share the webinar with you now, and webinar PPT presentation with you now. You can use that to solve the remaining 2 questions also. So from my end, I hope whatever I've discussed today was helpful. There are 2 more, as you can see, 7 and 8, which I would want you to try it at home if you want to. Another important thing, 2 more things which I want to talk about is, number 1 is that after doing this webinar, after going through the PDF once again, if you want to try out questions, practice questions from quizzes, we have a few live session quizzes on our platform. So if you are a student, obviously you know that you need to go to Final Frontier and access the live session quizzes. Okay, those of you who are a student who are attending the webinar. If there's anyone who is not a student and if you want to access it, okay, we have it in our free trial page also. So if you haven't registered for a free trial, you can register it as the name says, it's a free. So you just need to go to your free trial, and at the end of your free trial in your course, you'll be able to see live session quizzes. Okay, so I would recommend going through the webinar once again if you want to clear your doubts by going through it again. But try out the quiz so that you will be able to actually validate if you've understood these or not. Okay, so that would be a very good way of validating it.